Very good morning, students. Welcome. This is the activity class, we can say. Okay, I have a simulation of refraction of light. We have what is refraction of light? You know that when a light travels from one medium to another medium, then it will bend. Okay, either towards the normal or either away from the normal. Okay. So here we have two materials. The first material is air medium and the second one is water medium. Okay. So now what you have to do, just we have to have a light, ray of light incident on the surface of um, the surface where they both the mediums are interact. Okay. That is incident a ray. See here. Okay. So if we incident a ray like this, okay, then it will be the partial of the light will be reflected and the most of the light will be refracted, okay, through the water, and it is slightly bending edge from the normal. See, if there is no water, then it will be go through a straight line. As it is a water is there, the different media is there, that's why it is bending slightly from the normal ray of light. Okay, now we'll just measure the incident angle and the refracted angle. This one is the incident angle. See, now I am setting the incident angle as 30. Now the refracted angle is a little bit 24, 23 like that. Okay. If we'll change that incident angle, I'm setting that is as 40. Now the refracted angle is nearly equal to 30 degree. Okay. So then I'm setting it to 50, the incident angle. The refracted angle is nearly 35. Okay. When I am setting the incident angle to 60, then it is nearly equal to 41 like this. Okay. So here we know that by changing the incident angle, the refracted angle will also change. Okay. Now we'll put it back, the protector. Then, so how much the light is passing refracted, is the same light is passing through after refraction? The no. So after refraction, the ray of light have a there is a decrease in intensity. See this one here we will see. So after refraction, the ray of intensity, the ray of light have 95% intensity passing through refracted through the water. Okay, if you change the material to glass, then the 91% of intensity is passing. Okay, then if there is a same medium, then the 100% will be passing, the 100% intensity of light will be passing. Okay, so now we'll changing the media to water only. Okay, see, if 95% is refracted through the water, then the rest of percentage 4.93 is reflect back to the air medium. Okay, so this incident angle and this refracted angle can be calculated. uh, the ratio of incident angle, the refracted angle can be shown by the Snell's law, which is refractive index mu. So mu is equal to sin I by sin R. Okay. So now next we'll see the rectangular glass slab. Okay. So this is look like a rectangular glass slab, but this is a square, and we all know that all squares are rectangles only. Okay. I can consider the squares as a rectangle. Okay. So when there is a light, okay, another thing I left. Okay, when a light is passing through a rectangular slab or rectangular glass slab, so I did that object as a custom. Now I will take as a glass. Okay, so glass, then a ray of light will incident on the upper surface. Then the ray of light will refracted through this one, and it will be passed through the other way as but it will be slightly displacement from the original ray of light. If the ray of light, the glass is not present, then it will be passing through a straight line. As there is a glass is present, that's why it is refracted through this, and there is a displacement here, and this displacement is called as lateral displacement, and this is depending upon the thickness of the glass and the angle of incidence. So we can, by changing the angle of incidence, uh, the lateral displacement will also change. Okay, and by changing the refraction, by changing the refractive index also, the lateral displacement will also change. Okay, the lateral displacement is depending upon three things. The first one is the thickness of the material, the thickness of the glass. Then the second one is the incident angle depending upon the incident angle. Okay, and the third one is the refracting index of the material. Okay, so then what will happen if the incident angle is zero, or we can say that we will incident the light normally, then it will be undeviated. Okay, it will go through a straight line only. Okay, the refraction of light here is undeviated. So in this case also, okay, this will put here. In this case also, if the incident angle is zero, then or the incident ray is normal to the surface of where those two materials are met, then the refraction angle should be also zero, and the light is undeviated, it is passing through a straight line. Okay, I hope you enjoyed this one. So thank you for today.